Good afternoon, folks. How are you today? We are in lab number 9, and our lab today is about this corrugated roof. So, this corrugated roof is in sinusoidal shape. So, the function that can represent this shape is sin x. And what we want to do is we want to find the total length of this curve when the length of this corrugated sheet is 16 units. So effectively what we are finding out is what is the original length of the flat sheet that we should begin with so that when we deform it in sinusoidal shape, we end up with 16 units of length of roof. So as you have learned in your calculus course, if we have a function, then to find its length, we need to integrate it. We need to integrate the square root of 1 plus the derivative of the function square with respect to x from a to b. So this is our length of the curve. So in our case, what we want is our function is sinusoidal. And we want to go from 0 to 16 units. So therefore, the length of the flat sheet we need to begin with is going to be integral of 1 plus derivative of sine x is cosine. So cosine square x with respect to x. Interestingly, this very simple looking integral cannot be evaluated analytically. It is called elliptical integral of the second kind. And before computers were easily available, we had to look it up in handbooks. So what we want to do is evaluate this integral by trapezoidal rule using strip sizes of 2, 4, 8, and 16. We are going to use rounded values with 7 correct decimal digits of this function so that we can look at our error propagation. Then we want to also perform Romberg integration on these approximations. We'll build another table, estimate the integral by Simpson's 1/3 rule. I have a spelling mistake here. Using h is equal to 2, 4, and 8. Remember, we use pairs of strip, so we can have uh, 8 pairs at maximum. And then finally, in the second part, we are going to estimate the integral by Gauss quadrature using 2 points and 3 points. Okay. So please prepare a template like this for trapezoidal, Simpson's rule, and Romberg integration. And then for Gauss quadrature, your template would look like this. So let's begin with our trapezoidal rule. So of course, we need to know what function we want to integrate. So let me fire up my template. And the first thing we are going to do is we are going to go in Developer tab, Visual Basic. We are going to insert a module, and our function is f of x. So that's what we want to integrate. And of course, f is equal to square root of, remember square root in VBR is SQR, 1 plus, and we'll put cosine x in parenthesis and then square it. And that's our function. So now when I press the down arrow key, it should capitalize those function names, and we know VBA recognizes them. Okay, so we have our function. Let's start our calculations. So this is second function we are going to do when we do Gauss quadrature. Okay, so this is what our table will eventually look like. Let's look at our formulas. So first thing we want to do is we want to round the function value at x to 7 digits. Okay, and we are going to take this formula, copy it, down, formula only. Okay, then we are going to enter our trapezoidal rule weights, which we know are 1 at each end, and that is true for, so we copy this formula everywhere. Same thing here. The reason I'm copying formula is I don't want to mess up my formats. Now for strip size, when it is 2, that means every point here we are going to give 2 units of weight to all the interior ones. Right? Of course, when we go to strip size of 4, we are going to throw out every alternate point just like we did with pencil and paper. So we can copy 2 cells at a time. Okay. After that, kind of we are going to eliminate this. So we'll just have 2 strips, and finally we have 1 strip only, right? Okay. So now what we are going to do is we want to multiply this times the weights and do a sum product. So we are going to use sum product function, and we are going to take column B values, function values. And remember, we are going to copy this formula, so we are always going to pick up these values. So we want dollar signs up front, the row and column number. So I pressed function F4 key. And we want to multiply it by these weights. Okay. Then our formula for the area is h over 2 times this weighted function sum. So we have done our first evaluation. So we are going to take all these formulas, both of these formulas, copy, and we are going to copy them across. Okay. So we have got our estimates. All right. Now let's set up our Simpson's 1/3 rule. So same 1 unit of weight to the first point and the last point. And then we give weights 4, 2, 4, 2. So on, right? So we'll take these two, copy them down. Now it'll be 0, nothing. We are going to ignore this, 4, ignore this, 2. So we are going to have 4 here, and we are going to have 2 here, and then we are going to have 4 here. right? And then we'll just have a single pair of strips. So 1, 4, 1, right? So we are going to do the same thing. We are going to take this formula because we are doing weighted sum here, paste it. And we are going to type a new formula because now we have h over 3. So h from here, divide by 3 times the sum. And then we are going to copy this formula across. There we go. So we have done trapezoidal rule and we have done Simpson's rule. Okay. Now we want 7 digits everywhere. So let's format that. Okay. Now we want to do our Romberg integration on trapezoidal values. So we want to take these 4 values which are in row form and we want to copy them into this column form. So the way to do it is we know we can change it from row to column by using transpose. So we transpose these area values. Since we are doing multiple, Control Shift Enter. Okay. So these were order h square values. Our strip sizes are in multiple of 2. So our first wave factor is going to be 2 square. So it'll be 2 square and -1. So what we are going to do, 2 square is 4 times this value minus this value, divide by 3 total weight. So we are going to copy this down. Now we have h to the power 4 values. So our wave factor is 2 to the power 4, which is 16. Other weight factor, -1, divide by 15. Now we can only do 2 pairs. Now we have h to the power 6 values. So 2 to the power 6 is 64. So we will get 64 times this minus this, divide by 63. So this is our best value and we can box it. So this is what our table looks like. You can go ahead and compare your values. First part here and second part here. Let's see if my best answer matches digit by digit. 2677910. There we go. Okay. Okay, now we need to create 2 plots. Our first plot is going to be strip size versus our trapezoidal estimate. So we are going to take these two and plot them. So insert scatter plot. And let's say we want dot and smooth curve. Okay, so we are going to take this, move chart to a new sheet so we can format it. All right, let's start adding chart elements. So start with chart title. So we have trapezoidal area versus strip width. Okay, axis titles, strip width, H. Vertical, trapezoidal area. Okay, so we have lots of digits here. You can see just one digit would suffice. So let's format axes and say one digit. Okay, so everything looks good. Let's put this back in our trapezoidal worksheet. So we're going to drag this down to the bottom here. Okay, another plot we want is that of Richardson estimate versus M. So let's go ahead and select M from this row and control key. These are our Richardson extrapolation estimates. Insert that. Let's move this chart, new sheet. And again, let's start with our chart title. So we have Richardson extrapolation area versus exponent error exponent M. Okay. All right. Axis error exponent M. All right. Vertical. Richardson extrapolation area. Okay. So this axis look right. This one again has too many digits. Let's see, 2 digits would be enough. So format axis, number 2 digits is enough. Okay, close this. All right, we are going to put this back, move the chart in trapezoidal, and let's just stack it right underneath. Okay, so we are done. Let's go ahead and make sure our print settings are right. So print, so we'll need to fit it to one page. Okay, so there we go. Okay, second part of our problem. Remember, we want to do the same thing by Gauss quadrature. So for Gauss quadrature, I'd ask you to prepare this template. So let's see what we do in Gauss quadrature. So in Gauss quadrature, what we do is, first thing we do is we transform our function integral into -1 to +1 gz dz. Right? So you may remember gz was b minus a over 2 times function at b minus a over 2 times z plus b plus a over 2. So we know a is, so we are going from 0 to 16, remember? So a is 0, b is 16. So b minus a over 2 is 8. And b plus a over 2 is also 8. Right? So our function gz therefore is 8 times function of 8 times z plus 8. Okay, so we are going to code this in. So this is the function we are going to add to module 1. So let's bring up the spreadsheet. Go to Developer tab, Visual Basic, and we are going to type in function g of z. G is equal to 8 times function 8 times z plus 8. Okay. All right. So let's close this window. Let's go to our Gauss quadrature. All right. It says enter W and Z values as shown in cells A6 through B7. So let's go ahead and look at our thing. So for 2 points, our weights were minus 0.5773503 and positive 5773503. Okay. Oh, sorry. These were the Z values. So let's move them to Z. Weights are 1 and 1. Okay. So let's go back. So we calculate our G, function G at this Z. So we are going to copy it down. Okay. So what is our formula? We are going to do weight times the function sum. So we do sum product of weights by function. And that's our value. So it turns out our true value is 19.5110.873. This is from the handbook. So our actual error is this minus this. So it's a huge error. Okay. So let's round this to 1 digit only. Okay. Now for the next one, n is equal to 3, we'll need these values. So 0.5555556. 0.8, oops, yeah, I'm doing right, 88889. 555, 555, 6. Okay, those are the weights. Z minus 0.774, 5967. Middle value odd values is always 0. 0.774, 5967. Okay, so we compute our function. Copy it down. And then we just sum it. Oh, or so some product, right? Some product. That's our, let's bring that formula table. So we copied WZ values, we did G, we copied it down. Now we are going to do sum. Sum product of weight times the function values, and that's our new number. Again, our true value is 19.5110873, and our actual error is absolute of this minus that. So we get even a higher error. So let's round this up. And that's it, folks. Now you might want to think, why is our actual error so high? Interesting, right? Let's box this. Okay, folks, so let's check our formatting. Print. We have everything fitting in. Okay, so we are all done here. So here is our lab grading rubric. So please check all your formatting, print setting for each sheet. File name should be lab9.xlsm. Remember, it's a macro. You have got two functions in it. And then, of course, submit it to my courses. Take care.